Hi everybody, welcome to calculator tutorial number 3 for Math 1342 Statistics. And the topics that we go over will be on that side, the calculator goes on that. Right, the first one we do is about distribution of sample mean. I just put that on highlight. Right, that will be for the first two questions. By the way, when I send out an announcement about the video, I will have an attachment. Will have this file, this document, so it will be easier for you to follow. Right, let's look at the first two prompts. So first, when we look at the prompt, the first one we have for the population, we have the normally distributed for the population, the mean of 115 and the standard deviation of 8. So we write out that is information for the population. Right, and then if 20 people are selected randomly, for the probability that the mean will be less than 117. So that is what we have for example. The sample of 20, and we want that the mean will be less than 117. Right. But before we do that, we have the mean of this sample, the mean of the mean is equal to 115, the same as, and the standard deviation of the mean is going to be sigma divided by square root of n. So 8 divided by square root of 20. Let's do that. Right. So we have that for the sample. And the question asks us to find the probability that the mean is more than 117. So let's just write the mean probability that the mean is going to be less than 117. And so this is the question. Right, let's put everything together. For this problem, we have the population that is normally distributed, so the sample size can be small. I just draw the curve here. The mean is 115, and we want to have 117 and less than that, so it will be and the question asks us the probability that will be less than 117, so pretty much this area. Right, so that area will be given by we use normal CDF. We calculate the area from all the way here to 117. Alright, so of course the calculation, the step will be on that side. Now let's turn on the calculator. Right. We will hit stat and go to the second variable. Right, second variable, and then we go to normal CDF option number 2, and we hit enter. Right. The very small number on this side we can use -999 will be enough, and then we'll let's have another 9 because this is a little bit big, the 117. Right, upper is 117. So we want to choose the number that is a lot smaller than this. If it is just 1.7 or 1 point something, then we can choose -999, but just be safe, put in an extra 9 here. Right. The mean is 115. And the standard deviation 1.789, and we paste. And we have that. Right, so we write normal CDF -999 to 117. The mean is 115. Standard deviation 1.789. Right, that's what we have. Let's switch the calculator real quick. Right, now let's go to 83 real quick. We do the same thing. So second variable normal CDF, we have to enter exactly like this. Oh, sorry, I did the wrong one. This will be 115. Right. So we use -999. That probably that will still the same as the other. Let me go back to the other calculator. Oops, to go from the beginning. Yeah, so negative 999 or 9999, it doesn't really matter. We should have that, the same thing. Right. Sorry, a little slow on the first one. Just want to set up everything correctly. Right, second one. Now we go to the second one, will be on the same topic. So we have the average will be has the means of 75 and the standard deviation of 4.5. This time notice that we do not see the normally distributed. Uh, 75 and the standard deviation of 4.5. That is the information of the population. For the sample, we have 81 golfer, and we want that to be more than 76. Right, so for the sample, first we have 81 of them. Now this is very important. The population, even though is not normally distributed, but the sample size is big enough, the central limit theorems allow us to do the calculation the same as before. Even though the population may not be normally distributed, it's still perfectly okay because that is bigger than or equal to 30. So that's why it's big enough, so it's good. Right, next. The mean of the mean is the same as 75. Standard deviation of the sample mean is sigma over square root of n. Sigma is 4.5 and square root of 81. That gives us 0.5. Square of 81 is 9, so that's just 0.5. Right, so that's what we have from the population, and we'll go to the sample. Now the question wants us to find everything that is more than 76. So that is population when the mean, we want the average. So the mean is more than 76. And this is what the question asks. Right. So we draw the curve. The mean is 75. So 76 will be on this side. And we want greater than 76 will be on this tail. And the probability will be the area of that given by normal CDF. We'll go from 76 to a very big number, so let's use 9999, and then the mean is 75, standard deviation 0.5. Right, that's what we enter on the TI-83. TI-84, we just fill out the form really. Right, so we have 76, go to 9999, the mean 75 and standard deviation 0.5, and now that will do, and we have 0.0227. To 8. Right. Right. So be just that. Right. So a few things, two things before we go to the next topic. The first thing is that for the population, the distribution of sample mean, the mean of the mean will be the same as the mean of the population. So I will write. So those are the same. The mean of the population and the mean of the sample mean will be the same, like that. And then, where do I put this? Right, I'll put it here. Mean of the population is the same as the mean of the mean, and the standard deviation of the mean is the standard deviation divided by the square root of the sample size. So that's what we have. Right, so that's the first two questions. So now we're done distribution of the sample mean. Right. Next, we find the z values for a given area. Right. Number 3. Zoom out a little bit. Yeah, that's better. Right. Now, on this one, we want to find the critical values for the level of confidence of 85%. Level of confidence will be right in the middle. So we know 85% is right in the middle. Right. Now, if 85% is in the middle, we have 15% on each side. So we have 15% on this side and on this side. Meaning half of that is 7.5%. Half of 15%, and everything on the left of this point will be 0.075 for 7.5% plus 0.85%. That will be all the area on the left of it. So So everything on the left of that point is 0.925, and to find the z values, we do the inverse normal of 0.925. This gives us the z values, so let's do that. Second variable, inverse normal of the area 0.925, and the mean and the standard deviation, we just leave it like that. By default, for z the mean is 0 and the standard deviation is 1, so we do that. And give us 1.440 of 4395. 3 decimal places will be good enough. Right, so that is inverse normal, and always enter the area on the left of z, and this is inverse normal, give us the z values, so that's why the 0 and 1 for the standard normal, 0 for the mean, standard deviation is 1. Now we do confidence interval for the population proportion. Right, that's number 4 on this. So the first thing always is we look at the question. The question asks for the 98% confidence interval for the proportion, so that means P. And for confidence interval for the population proportion, that's going to be 1 proportion Z interval. So hit stat and go to test, option one proportion Z interval. All of this guideline is on the formula chart, where you will tell us on what kind of test or what kind of confidence interval we use what option on the calculator. So we're going to use this. This one, the calculator TI-83 or TI-84 is the same, so I'm just going to do 1 here. So we're going to have that. So to be 1 proportion Z test, we have to have X and confidence level, and then we can calculate. Right, so now we go back to the problem. We have 320 out of 490. So X is 320 over 490, and it's always bigger than X. So we have that. And confidence level of 95. And then we just calculate. So we enter 320 for X, the smaller number, and 490, and then we calculate. So we have 0.611 0.695. So which means 90. Wait, the question is 98%. Sorry, I need to change that. Again, one proportion z interval, that is 88%. 98, that is. Sorry. So we have 0.603 and 0.703. So as you see, the bigger percent on the confidence interval, we're going to have the bigger interval. The number, the range of the number will be wider. This will be 98. Anyway, so between 60.3% and 70.3%. Yeah, the answer will be just an interval of numbers between two numbers. I forgot to do this. Right. Next, the next question asks us about the sample size. Even though this has nothing to do with the calculator, but just gonna do that anyway. So this question asks us about the sample size, and we look at the formula will be n equal to 0.25 z alpha over 2 over the error square. Right. So we know the more than not differ more than 3%. So we want the error to be 0.03. And we have 95% confidence interval. Will give us the z. So we did the same thing as we did for that problem. So 95% in the middle, meaning 0.05% on each tail on the left and on the right. So the total we have on this, the total of this is 0.025, half of that plus 0.95, and then we do the inverse normal of that will be 0.975. So we do that. Second variable, inverse normal of 975 1.9599, so that's 9.60, right? And then we're going to put that in here. So calculation, we have 0.25 z alpha over 2 would be 1.960, and by more than 3%, and we do that. Right. 0.25 and then we need a fraction, so I open parentheses and then alpha y equal to, the bottom menu pop up and I hit enter, so I will have a fraction, and enter 1.96 divided by 0.03 and we square. So that's how it look like, and enter, and we have 1067.1, and we always round up to 1068, always round up. Right, that's the confidence interval for the proportion and the sample size for that. Right, next. Right, next, number 6. This is the confidence interval for the population mean. It's not gonna put in. Right, confidence interval for the population mean. Right, and that will do the t interval as you see on that side. Right, the t interval would have, we can have the data or the statistic. We have one for the data and one for the statistic. Right, so we hit stat, go to test, and this is t interval. Right, the first one we have the statistic. Right, so this is t interval. The windows, in this case, we have the input, this time we choose the statistics. That's what we have: mean, standard deviation, and n, and then C level. Right, let's look at the problem. This one has normally has normal distribution, which is good. The sample size of 16, so we have 16 of them. The sample of 16. The mean of 645. and the standard deviation of 31. Right. Confidence level, confidence interval of 95%. So we're going to enter that into that screen. So choose statistic, export. The mean is, just go down, 645. The standard deviation 31, and the mean are the numbers 16. Confidence interval 95%, and we'll calculate. We have 628.5 to 661.5, so about that. So that will give us the confidence interval. For the mean, population mean, we use the t interval. That is because we do not know the standard deviation of the population. Otherwise, we use z, but that's also work. Right, so that is where we have the statistic. Now if we have the data, like on number 7, we do not know the mean and standard deviation. We do know there are 7 of them though. So first, we should put this into a list 1. So put that information into list 1. And this question also 95% confidence interval for the population mean. So that also t interval. So input data. This time we choose data instead of the statistic. Right. So we do need to put this in the list 1 first. So stat, edit. Now enter 60, 58, 70, 63, 64, 72, and 67. Right, we have 7 of them. And right, so we have that in list 1, which is good. So second mode to go back to the home screen. Right, now we do the t interval again. So all the tests under statistic and test. So pretty much everything that has to do with confidence interval and test, hypothesis test will be in here. So t interval, option number 8. This time choose data. Right. When we say list 1, do not mix up. The list is list 1. Do not mess up with the frequency for that. And we do have 95%, so it's good. Keep it on. And calculate. Right. Do that again because I forgot to write out what we have on the screen. Just choose option 8. Right. So data list will be L1. frequency. You don't need to do this on the test now. I just want to write out here so you it is easier to follow. And sea level of 0.95. So we do put all that in and calculate. And we have between 60.13. The decimal places are not really important. I mean, if the number is good enough, then it should be good enough. So we have that. So that is the confidence interval for population mean. Population mean, we're going to use t interval. So you see the formula over there. And if we are given the data, we use the data stored in the list, and usually L1. And if we are given the statistic of the sample, then we're just gonna give it under statistic, and either way give us an interval of numbers. Right. Next we have the sample size. So the sample size for the mean the alpha over 2 times standard deviation over E squared. Right. Once again, this one is 90%. We need to use that to find the alpha over 2. So 90% confident, meaning 90% will be right in the middle. That means 0.1 on the outside, on both tails, meaning 0.01, 0.05, sorry, half of that, 0.05, 0.05 and plus 0.9, so 0.95. So 0.95 will be on the area on the left of these z values. So inverse normal of that. So inverse normal is under distribution. Second distribution inverse normal, and 95%, 0.95. I'll just calculate the mean and standard deviation. Don't need to mess with that. I'll have 1.645. Right. Now that number is going to be the z alpha over 2. So we have 1.645 times the standard deviation 5 ounce over E within 2 ounce. So we have that. So let's open parentheses and have a fraction. So alpha y equal to it and 1.645 times 5 divided by 2 and close parentheses and squared. We have 16.9, and that of course we're going to round up to 17. So that is that. And with that, we're done with the confidence interval. Now we go to the hypothesis testing. Right. Hypothesis test. Now we look at this problem. So usually the problem that has the hypothesis testing, we see that alpha is given. Alpha is 0.05. Test the claim that the cone it is not biased. Not biased meaning the probability of head or tail equal to 0.5. So let's say the probability is equal to 0.5. That will be probability of getting a head. Get head on a cone. Right. And so we write that. Then we write the complement. Going to be not equal to 0.5. Now, with that, we will form the hypothesis. This will be the null hypothesis. And this will be H1. So the first step is we write the hypothesis. This won't be a two-tail problem. Next, alpha 0.05. Right. Step 3 and 4. We use the calculator. Right. This what we have is we're going to do a test, and we have a proportion. So, like I said, all the tests will be in the stat, and under the test, the third tab. So we go to this one proportion z test. So the proportion will go with the z test, the mean will go with the t test most of the time. Right. Now I just write that step down. One proportion z test. We need to indicate p naught, x, and the proportion not equal to p naught, less than p naught, greater than p naught, and then calculate. Right, so that will be on the calculator. Right. Now we focus on the null hypothesis. Sorry, not that. The alternative hypothesis. We have the proportion not equal to 0.5, so we're going to choose not equal to, and 0.5 in that case will be the p naught, will be whatever happened on the right side of it. The left side is the proportion, so we have proportion not equal to p naught, and p naught is 0.5. Right, x is, now we look at the problem, 1,000 times and 570 heads, so 570 out of 1,000. Now we calculate. So 0.5 of x 570 and 1000 not equal to, and then calculate. Of course, we don't have enter anything that has alpha in it, so we don't need that on the calculator. Right. When we calculate this, we have p equal to, the key here is when we do this, we only take the p values. The p values equal to 9.55. The e here meaning times 10 to the negative 6, which means it's going to be 0.012345, and that is extremely small number. And then the last step is the conclusion. So the conclusion here we have p is a very small number that is way less than alpha, 0.05. That number is less than 0.05. If p is a small number and less than that, we will reject the null hypothesis. So less than, reject. So in that case, we write the conclusion like this. There is enough evidence. There's enough evidence to support H1. And we reject H1 to support that P is not 0.5. And which means the coin is the biased one, because the probability to get head is not 0.5, meaning this is not a fair coin or a bias coin. So again, P less than alpha, reject the null hypothesis, and there is enough evidence to support that the alternative hypothesis, P not equal to 0.5. Right. Before we go to the next problem, I'll go over the details a little bit more. Right. Right. Let me just write the important things. The summary of hypothesis testing with the p-values. I wrote this in class. So the null hypothesis is the status quo meaning it has the equal sign. Right. So HO is the status quo. When P is low, then it must go, and that is when must go meaning this one has to go, meaning we reject it. So if P is low, then we will reject the null hypothesis. Right. Next. The engineering school major university claimed that 20% of the graduates are women. So that is the claim, and we have 20% are women. That is the claim. So we start with P equal to 20%, and the complement is not equal to. So the first one we have is the null hypothesis is P equal to 0.2, H1 not equal to 2, alpha equal to 0.05. So that's just need to do this real quick. Right. Now this is for the proportion, so that will be z test, and we have only one proportion. So stat, turn it on. Stat test, and this is proportion, meaning we're going to use the z test and option here. Right, so that is what we need to have. P naught x and Rob and we're going to choose this one because that's what we have for the alternative hypothesis. Alternative hypothesis is P not equal to 0.2, so that's not equal to, and we have 0.2 here for P naught as well. I'll just calculate. Right. We just need to have x and n for the sample. The class of 210 students, and we have 58 are women. So we have that. So 0.2, and we have 58 out of 210 and not equal to, so we just calculate, and we just look for the p-values. This step 3 and 4. Step number 5, we calculate, we have p-values is, once again, our p-values is less than alpha of 0.05. So if it's less than, so if p is low, then it must go, meaning we'll reject the null hypothesis. And if it's reject, the conclusion will be there is enough evidence to support the alternative hypothesis, meaning the proportion is not 20%. To support that is not 20%, that proportion is not 20%. And always, if it is rejected, we said there's enough evidence to support. And always with support or not, it's going to be this, the alternative hypothesis, which is the proportion is not 20%. So, which means that the school is not believable. Right. So the last two questions are the test for the population proportion. Now we'll go to the test for the population mean. Right. So 11. First the claim that the mean lifetime of live bones is at least 1000 hours, and at least the mean and 1000. So we have the mean, at least meaning greater than or equal to 1000. And if that is the case, the complement is going to be less than 1000. Right. So the first step is to establish the hypothesis, null hypothesis, alternative hypothesis. The null hypothesis, we have the equal sign, so we just write that equal to 1000, and not equal to, I mean we have less than instead. Right. Next, alpha. Right. This one we will test the mean. The mean will have the t-test. So we use the t-test here. And we assume that all the conditions are satisfied. So now we do that. So the t-test. That the t-test, and this one we have the statistic. We don't have the data, so we go with statistic, and we write down what do they have. So input, like data, and we choose stats, the mu naught, x bar, standard deviation, n, and mu not equal to, less than, greater than, and then calculate. Right. First of all, we look at the alternative hypothesis, and it is less than, so we have to choose this. I choose red. So and then the 1000 will be on that side. So less than 1000, we choose less than 1000. And then we have the information for the sample. So we look at the sample, we have 25 for n, 25 live bones, and the mean of 980, and the standard deviation of 80 hours. So we have that in the calculator. So the mean of 1000. The sample mean for that sample 980, standard deviation of 80, and there are 25 of them, and this one is less than, and we'll calculate, and we have the p-values of sorry, this is step number 5. This is 3 and 4. We have p values we have is equal to, on the calculator, 0.111, and we have that is bigger than alpha. If it is bigger than alpha, so if it's low, then we reject it. If this is bigger than, so we do not reject it. And the conclusion would be as follows. There is not. So if we reject, we have enough evidence. If we do not reject, we do not have enough evidence. So there's not enough evidence to support the alternative hypothesis, to support that the mean of the libel is less than 1000 hours. Right. So whether we have enough evidence or not is always support the claim. Not support the claim. Right, so that's what we have. Right. Next will be similar. Right. The claim that the mean for the first hour is less than 5 minutes. So we write the mean is less than 5 minutes. So the complement is greater than 5. So the first step is write out the null and alternative hypothesis. This one does not have the equal sign, so will be H1. This one has the equal sign, and we always write just equal sign equal to 5. That is 5. Right, alpha so that's what we have established from the prompt. Next, this has to do with the mean, so that we use the t-test again. Right. So t-test, and so again let's write out what we have on the menu. There for the stats, we will choose statistic. The mean export standard deviation and right. Now we look at the alternative hypothesis. We have less than, so we choose less than. The mu naught must be 5. Right. For the sample, we have in here the sample 20, meaning there are 20 of them. The mean of 3.7, standard deviation of 2.1. So that's what we have. And then we calculate the p-values for that. Right, so 5 export 3.7, 2.1, and 20, and this is less than. So yeah, that's what we have. And calculate, and we have the p-values. And this is less than alpha 0.01. So if it is less than, then we'll reject. Again, p is low, it must go, so reject the null hypothesis. So we write there is enough evidence to support that the mean is less than 5 minutes. Right. Meaning that this claim is a valid claim. The claim is good. It is indeed less than 5 minutes. So that is the hypothesis test for the population mean. Next we do hypothesis test for two population mean. This will be in chapter 11. This is straightforward, pretty much. Now we see that there are two proportion and that equal to, so instead go to test and we have two proportion z-test. Right, so we have two proportion and everything's here. Alpha is that also, so 2 prop z-test x1 n1 x2 n2 p1 not equal to p2 less than p2 greater than p2 and calculate. that we have on the calculator menu. We have two proportion and we use z-test. Right, now when we look at the claim that P1 equal to P2, meaning that is going to be the statement and then the complement is going to be not equal to. So we're going to write null hypothesis equal to alternative hypothesis not equal to. It's still a complement in those things. Alpha is still 0.05. So that's the first step, that's the second step. Now just fill out all of this information. N1, there are 50 of them. Sorry. X1 is 35, so 35 first. For X1, N1 is 50. Maybe I just write down first. N1 is 50, X1 is 35. X is always less than N. N is 60, X is 40. X is always less than N. I should have those. 35, 50, 40, and 60. And this one is not equal to, so we choose not equal to. That one. And then we calculate 35, 50, 40 is not equal to it. Calculate. And just like I said, just focus on the p values here. And that is much bigger than alpha. Alpha 0.05. So if it is bigger than, we do not reject it. Right. Right. So we write there is not enough evidence to say that, to claim that, to support, that's better, to support that P1 is not equal to P2. We always support or not support the alternative hypothesis. Right. The next one will be similar than as before. So a little bit more confusing when we set things up though. So we have elementary school teachers and the high school teachers. So let's assume that everything that goes with elementary school teachers is 1. So for example 1. We have 100. X is 15. Sample 2 and 2 is 180 and X2 is 36. Right now the claim that is the proposed high school teachers. So we have the high school smoke greater than the elementary teachers. The high school is 2 and the elementary school is 1. So P2 is bigger than P1. But when we write it, always P1 first. So which means the same thing as P1 less than P2. So that will be the alternative hypothesis. So the first step, set up the hypothesis. This is less than P2. The elementary school teachers will smoke less than the high school teacher. Or high school teachers smoke more than the elementary school teacher. This will always have equal to alpha 0.01, and the test will be the same as this. To prop C test x1 n1 x2 n2 p1 not equal to p2, less than p2, greater than p2, and then calculate. Alright, so we have less than P2, so we're going to choose this. That's always the same as the alternative hypothesis. This one we want x1 is 15 and 100, x2 36 and 2 180, and we have that. When we calculate, we just take the p-values as always. Right, stat 2 proportions z test, proportions z test, number 6. That. Alright, 15 for x1, 100, 36, 180, and this is less than, and calculate. The p-value is 0.14 something. And that is bigger than alpha. If it is bigger than alpha, we do not reject it. We only reject if it is smaller. So we write there is not enough evidence to support that. Will be this, meaning the elementary school teachers will smoke less, or the high school teachers smoke more. To support that, this high school teachers P2, small more. Right. Because alpha is bigger than, P is bigger than alpha, so we do not reject the null hypothesis. And so we always support this. So P1 less than P2 or P2 is more than P1. Those are the same thing. So P2 is more than P1, meaning the high school teachers smoke more, or we write the elementary teachers smoke less. Either way, it's still the same statement. And so, as always, if it is not reject, there will be not enough evidence. Right, so that is 14. Right, the last one I forgot to put the formula over there. So once again we have two proportion. So we just go to stat. Two proportion z interval. This one we want the confidence interval. So to prop the interval x1, we have x1 is 35, n1 50, x2 40, n2 60. We have this number before. And then next, the sea level of 95, and then calculate. (15) x1 of n1 is 50, x2 40, n2 is 60. Just make sure that you enter the n and x correctly. X is always smaller than n. 95% confident, and we calculate. Let's look at this again. Oh, sorry. This is 35. I put 15. So I wrote 35, 50, 40, 60. Right, sorry. I'd better go back and check it. Right, so we have that. Right. So pretty much we have two proportion. We have confidence interval, and we have two proportion interval, and it only have the z option. So pretty much we have that. So that is the confidence interval for two proportion. So pretty much all of this test kind of the same thing. All the confidence interval we do similar thing. Just go to the correct option and then fill out what we have in the form, and then pretty much you calculate first. For confidence interval, we just have the interval. So meaning P1 minus P2 is between this range, within that interval. And if we want to do the test, all of our tests in class, we're going to use the p-values. So always find the p-values, and then we compare. Right. So that's the end of it. So this will cover almost everything that we need for test 3 that require to use the calculator, and pretty much this should cover everything. I hope this helped you to prepare for the test. Thanks for watching.